Good morning all. Today we will discuss about the Module 1 DC generators. In this we are talking about the DC machines. In DC machines, we are categorized into two types, DC generators and DC motors. Now we will discuss about the DC generators. In DC generators, electric generator is a machine which converts mechanical energy into electrical energy or power. The energy conversion is based on the principle of production of dynamically induced EMF. So before going to produce a EMF in a DC generators, there are three requirements are essential: conductor, magnetic field, and mechanical energy. And coming to the working principle, a generator works on the principle of Faraday's laws of electromagnetic induction. So according to Faraday's laws of electromagnetic induction, a conductor is moved in a magnetic field, and EMF is induced, and the magnitude of induced EMF is directly proportional to the rate of change of flux linkage. This EMF causes a current flow if the conductor circuit is closed. So generator mainly works on the principle of Faraday's laws of electromagnetic induction, and the conductor is serves the magnetic field, and EMF is induced in that conductor. And in this conductor the current flows when the circuit is closed. So this is a cross-sectional view of a DC machine. In this, it is shown the commutator, field winding, armature core. In this cross-sectional view, the cross-sectional of DC machine, there are many parts: field winding, pole core, pole shoe, interpoles, and commutator, and also frame, armature conductors, field rheostat. The construction of DC machine contains the following parts. Mainly contains the following parts. Those are field system, armature core, armature winding, commutator, and brushes. So this diagram shows the field winding. Rotor and rotor winding. In this it shows the rotor and rotor winding. So in this we are using the armature winding. There are two types of armature windings. One is the lap winding, another one is the wave winding. Lap winding, in number of parallel paths in lap winding, A is equal to P. That is, number of parallel paths equal to number of poles in a DC generator. The wave winding is designed in such a way that A is equal to 2. That means number of parallel paths A is equal to 2 always. Voltage generating capability of the lap winding generators is low. Voltage generating capability of the wave winding generators is high. Then coming to the current source capability, in lap winding high, in wave winding it is low. The number of brushes sets equal to the number of poles in lap winding, and equals number of brushes equal to the 2 in wave winding. So the main important parts, one of the part is field system. It is for uniform magnetic field within which the armature rotates. Electromagnets are preferred in comparison with the permanent magnets. They are cheap. Electromagnets are cheap, smaller in size, produce greater magnetic effect, and field strength can be varied. The field strength of magnets can be varied. Field system consists of the following parts. yoke, pole core, pole shoe, and field coils. Armature core. The armature core is cylindrical and it is made up of copper. It has high permeability, silicon steel stampings, and it is impregnated. And it also armature core is laminated to reduce the eddy current losses. Commutator. The one of the main important part in a DC generator is commutator. The commutator is connected with the external circuit, converts AC into unidirectional current, and it is also cylindrical in shape, made of wedge-shaped copper segments, and each commutator segments are insulated from each other with a thin layer of mica. And also, each commutator segment is connected to the armature conductor by means of copper strip called riser. The number of segments is equal to the number of coils. Carbon brushes. Carbon brushes are used in a DC machine because they are soft material. It does not generate spikes when they contact commutator to deliver the current through armature. Carbon is used for brushes. Carbon is used for brushes because it has negative temperature coefficient of resistance. Carbon is used brushes because it has negative temperature of resistance. Self-lubricating takes its shape, improving area of contact. So generally the carbon is made up of thin layer of mica. Brush rock and holder. Brush holder is used to hold the brushes. So your carbon brushes are having the following parts: brush leads, brush rocker, front end cover, rear end cover, cooling fan, bearing, terminal box. Now we will go to the EMF equation of a DC generator. In the EMF equation of a DC generator, there are some certain important terms. Let phi is equal to flux per pole in Weber. Z is equal to total number of armature conductors. P is equal to number of poles. K is equal to number of parallel paths. N is equal to armature speed in RPM. Next, EZ is equal to EMF generated in any one of the parallel path. So according to the Faraday's laws of electromagnetic induction, whenever conductor cuts a magnetic field, an EMF is induced across the conductor. Flux cut by one conductor in one revolution is equal to P into pi. Because in a DC generator, it is designed with a P number of poles and flux per pole is phi. The total flux produced by the total flux cut by one conductor in one revolution is equal to P into pi. Flux cut by one conductor in 60 seconds is equal to P phi n divided by 60. Average EMF generate generated in one conductor is equal to P5N by 60. Number of conductors in each parallel path is equal to number of conductors in each parallel paths is equal to Z by A. So the EZ is equal to P5ZN divided by 60 into A. Types of then we will move on to the types of DC generators. DC generators are broadly classified into separately excited generators and self-excited generators. So in the self-excited generators, they are again classified into DC shunt generator, DC series generator, DC compound generator. So in DC compound generators again divided into two types: cumulative compound generators and also differential compound generators. Types of DC generators. In this type, it is categorized into DC machines are divided into two types. Those are DC generator and DC motor. Again, DC generators are divided into two types: self-excited DC generators and separately excited DC generators. Self-excited generators again classified into series generator, shunt generator, and compound generators. Compound generators again classified into long shunt compound generators and short shunt compound generators. Compound generators further classified into short shunt and long shunt compound generators, cumulative compound and differentially compound generators. There are certain losses in it. DC generators. Copper losses are, there are two types of losses. One is called the copper losses or variable losses. Second one, stray losses are constant losses. Stray losses are constant losses. Stray losses consist of a iron losses or core losses, and D, windage and friction losses. Second one, iron losses occur in the core of the machine due to changes of magnetic flux in the core. Consist of hysteresis loss and eddy current loss. Hysteresis losses depends upon the frequency, flux density, volume, and type of the core. So here the iron losses is divided into two types. Those are hysteresis losses and eddy current losses. Hysteresis losses depends upon the frequency, flux density, volume, and type of the core. Eddy current losses is directly proportional to the flux density, frequency, thickness of the lamination. Windage and friction losses are constant due to the opposition of the wind and friction. There are certain applications of different types of generators. Shunt generators having the applications lightning load, applications of shunt generators, lighting loads, battery charging, and the series generators for the arc lamps, as a constant current generators, as a booster and DC feeders. The applications of these generators have limitations. Separately excited DC generators. In the separately excited DC generators, the application of these generators have limitations because they need a separate excitation for the field winding. Some of applications of the electro refining of material or electroplating. Next, coming to the cumulative compound generators, it is used for domestic lighting for energy transmission over a long distances. Differentially compound generators. This type of generators are very rarely used due to their drooping load characteristics. One of its important application is electric arc welding. Thank you, one and all. Okay, the meeting will end in it. Now the meeting will end.